Alright, so let's begin this week's lecture. So this week's lecture, we're going to study two new new topics. The first one is the antivirus software, and the second is the dynamic heuristic analysis. Okay. So let's begin with a quick review of all the topics that we learned so far. So in this semester, we start from the very basics. We're starting from the basics analysis, where I shows you that I first shows you a malware example where we use this DLL injection, which brings you to some ideas of how this malware works. And then after that, we start from the very basic things. The first is the basic analysis, where first we know that basic analysis basically just try to quickly glean the information from the samples, from the malware samples. For example, we calculate the hash a value. We just gave the name, the file malware with a name by using this hash value, and also we try to using some strings, those kind of like softwares, to find out the strings contained inside the malware. So this basic analysis help guide and focus on advanced analysis. And then after we finish this basic analysis, then we'll quickly move on to, there's actually two advanced analysis that we learned so far. The first one is the static analysis, which we use to see what is going on and then confirm suspicious errors during basic analysis, and also identify the functionality. Basically, we use the several tools for helping us to do this static analysis. For example, we use the GDB and their Linux system, and then we use ODBG or some like P viewers like softwares to analyze the structure of the code. Right. And then after that, we also try the advanced analysis, the dynamic version, where we the dynamic analysis means that we try to run this malware in a controlled environment, right? So we know that we can use ODBG, the ODDebug software, to help us to achieve this goal, where we just use ODBG to load this program, and then we can fully control the program, and then let this program to, like, say, control the running flow. We can try to see whether if they have some like new code path by changing some values of assembly instructions. We can also change some data. For example, that's what we did for the lab 1, right? So changing some of the strings, right? So this is also basically what we do inside this dynamic analysis. And then after that, we also study a lot of like basic concepts like Windows API and systems. We start from the very basic one. We start from this hook, and then I talk about this API hook, and then while we're studying it, we understand how does this malware interact with the Windows system? How does Windows make malware authors lives easier, right? So that's the reason why we choose to using this Windows XP system, right? And how does make their life harder, right? So once we move to this 64-bit operating system starting from Windows Vista, then it will become more and more harder. Windows Vista, Windows 7, and then now Windows 8 and Windows 10. They are just keep adding that new protection mechanism, so it's really hard to break the system, and therefore it's really hard for me to shows you how some of the concept in this newer version of the systems. All right, so that's basically everything that we learned so far. And then in the previous lecture, we almost dive into the most difficult one, which is the rootkit, the kernel level rootkit. That part is I can say that's very hard. It's even if you are like a malware analysis expert, you probably won't be able to like know everything in that area. So that is just like something that you probably gonna learn once you how to say, if you're in this area, right, like work in this area, then you will eventually need to learn those things. Right, so in today's lecture, we're going to step back a little bit and then to think this malware analysis from a different perspective. So in the previous lectures, we always act like a black hat hacker. We try to study how to hack the system, right? So we know that the reason why that teach in that way is just try to show you how this malware works, right? So now left to think how to like detect those malware, how this antivirus software works. Right? So I think I also mentioned similar things in the previous lectures when we talk about this rootkit, this kernel rootkit. I said that probably the antivirus software will basically do some similar things, very similar to the malware, right? So they're gonna do something like an API hook or a kernel who access DT hook, something like that. So, but in today's lecture, I want to like give a more like generalized, but basically more like a comprehensive study to show you what is the antivirus software and how does they actually work. So how they actually work. So nowadays, the antivirus scans our system is on this real-time basics. Right? This is the this picture shows you this virus total, which is a website that you can upload your virus samples, and then they can scan. And then once you click the scan it, they're gonna check and then report, and then generate a report and shows you what type of malware and then what is the information about this malware. So the information is analyzed based on the origin of the information, like source of the information. So the information is analysis based on the origin of the information, like source of the information, and operates differently depending upon the source of information. So that's how what is AV antivirus software works, how this works, right? So from the top level view, right, the antivirus softwares you can consider them like working this way, like the shows here in this figure, where we have the executable files, and then if you do some operations, all these operations, all this information will be gathered and sent into this antivirus software, and then eventually this operation will be eventually copied onto this hard drive. So antivirus software is like act like more like a middleman in between the executable files and the actual like operating system. So if the file is found malicious, then the information will not be copied onto the destination location. Right? So here the destination in this case is the hard drive. So you can consider this antivirus software is more like a shield, right? An extra protection layer in our operating systems. So that's usually how this antivirus software works, or it's supposed to work, right? So first, there's just every time when you try to run some softwares or programs, then there's just there's two possibilities takes place. So when the data is found to be legitimate, then the scanner forward that data to the destination location. But when the virus is detected, then a warning is sent to this UI for users action. Interfaces may vary, right? So that's usually what we see. This is how this antivirus software how this works, right? So that's the antivirus software. And then here shows you the process flow of working of this antivirus softwares. So you can see that we have this source system and we have the destination system. And in our case, it could be a hard drive or the memory, right? So every time the source system they try to do something, the antivirus software is like always act in the middle, right? So they're gonna like first interpretation of the information, scanning of the information, and then if this virus in it, then they're gonna do disinfection and then alert, or once they finish disinfection, then they can put into the destination system. So this AV scanner keeps scanning information on real time, right? So that's the process flow of working of antivirus software. Actually, I think this figure is not that precise, because you can see that if there's no virus, then I would say that they should directly go to the. What I'm saying is that they should, if there's no virus exist, then they should directly jump to the destination system, right? So start from this step, then they're gonna directly jump to the destination. You don't have to move to this infection. This infection is only works if there's a virus in it, right? So, okay, so now that's the top level view of the antivirus software, and I'm pretty sure that most of you would probably feel boring about when I talk about this, because everyone knows how antivirus software works, right? I believe it or not, or maybe in the next few years, maybe some of you guys probably some of the new students in the next generation, they probably will have a difficulty in learning, in understanding the things, because antivirus software is becoming more and more like transparent in the future. It's actually built-in mechanism for our systems. Unlike that, like 10 years ago, everybody knows that you need to install antivirus software for your Windows systems or for operating systems. But nowadays, most of the computers users, they no longer install these antivirus softwares, or they just think that they're already built into the system. So that's the reason why that all this previous slides is looks to be trivial, but it's not that trivial. All right, so in the future. Anyway, so let's talk about this AV antivirus detection techniques. So first, we're gonna talk about this the very basic ones, the scan engine. So in the Stone Age, right, like 20 or 30 years ago of our computer, most of the antivirus softwares, back in that time, there's no or they have internet, but not everyone is connected to the internet. So back in that time, the antivirus software is most of them is rely on the so-called signature-based detection, also called the string-based detection. So back in that time, creating an antivirus software is very simple. All you have to do is just create a database system. So you can see that the antivirus software is the one that in the middle, and then we have this various dictionary where it's just a database. We have a computer system where there contains a lot of files. So what they do is that you can just run the software, and then there's a button. I think most of you guys, when you're a young child, you probably work on this way. They just click to help your parent or your grandparent to find fix the computer. Then you just install this antivirus software and then click scan, right? So that's a button called scan. And then what happens is they're gonna start scanning all the files in your computer system. What they really do is that they just try to run this hash function or some other signature-based algorithms to generate a signature for each and every files, right? So this antivirus software maintains dictionary of the signature of known viruses, malwares, spywares, everything, right? So they have this various database. And then if they find a match, so let's say if you are using, like say some functions like SHA 256 or MD5, for example, MD5, right? So back in that time, we just using some similar ones, MD5. And then you generate the hash value, and you find the hash value inside your virus database, then you just output virus found, right? So it's very simple. And I believe everybody, you are most of you guys are already a senior students, so I believe you should be able to immediately create antivirus software, like with using like Python or Java in less than 100 lines of code, right? So just calculate scanning the system, all the files, and then check MD5 and then compare with the one in the database. Very simple. Disadvantage of this type of scanning, of course, the disadvantage is that if the virus change a little bit, then you probably will see a completely different like signature. Well, it just depends on how you generate the signature, right? So if like say you're just using this MD5, the one that I mentioned here, then a little bit change, like say the hacker or the malware's author, they just changing the name or just adding one characters, like say they just adding some strings, then they're just adding some new functions or anything, then the MD5 value will completely change. So therefore you won't be able to see this new virus. So it's very easy to like bypass your mechanisms. Well, so basically it's just like a battle between the malware's developer and the antivirus software engineer. So you can see that the signature-based antivirus softwares, the most important part is how to retrieve the signature. If you simply just MD5 the whole files, that'll be a problem. So some of them try to find a more clever way to to retrieve the signature. For example, they find some ways to only like retrieve or only like take part of the files, like something like this, right? So here I can show you there's actually all these malware's empty files is available online, which basically you can actually use these files to create this very basic signature-based antivirus software. So here is the website URL, right? So this is a video recording in 2021, so that's the website here. But you can, in the future, you can also see that from different class website. Right. So if you go to this link, right, the link that post here, you can see that here is all the malware simple MD5, right, list of the malware, right? So this file is huge, right? They just contain, they just 00001. They actually have 10 of them, so I only upload 1/10 of the malware signature. So you can see that this one you can just use this to build an antivirus software, but we know that this is in nowadays no one uses this kind of like a basic analysis way to scanning or detect the malware. Nowadays most of this malware is basically detect using a more complicated ways. Okay. So now we know that if this is a malware, then simply using signature based is not that good enough. So therefore, some of them come up with a better way to do this is so-called heuristic based detection. So the heuristic based detection is try to use to detect new and then unknown virus in your system that has not yet been identified. So these ideas behind this is to try to like find out some of the like common part or inside this malware. So based on the piece by piece examination of a virus, and then looking for some sequence of instructions that differentiate the virus from the normal programs. And I know, I'm pretty sure that most of you guys already know how to do that because you already done this lab 2, which requires you to develop your own heuristic-based detection. You know that the idea is very simple. Like say if the memory offset for each like export functions is a fixed value, then we can think that is malware. So we just create a lot of rules, and then we just try to use these rules to filter out this malware. So this is called heuristic-based detection, right? So so that's basically the two detections. So signature-based and heuristic-based. So so if you are living like 15 years ago, then if you create a program with these two things like built inside, then you can just claim that you're like state-of-the-art antivirus softwares. But it's no longer the same case in nowadays, right? So let's talk a little bit about this antivirus bypassing technologies. So we know that all these bypassing technologies are the techniques that hackers and crackers already knew. So like for example, they can use some so-called binders and packers, which I mentioned early in this semester, to bypass it. They can use splitter to split this malware into multiple pieces. They can try to convert the code from this exe to some other client-side script, right? Like they can do code obfuscation, right? Just like what you do, try to like try to bypass some of like say detection mechanisms. Code obfuscation is just like say you're just adding some like redundant functions or variables, and then try to do it in a very complicated way. But eventually, all you do is just simply maybe just coding a certain like malicious functions. Right? Just try to bypass these detection mechanisms, and then you can also like some of the hackers, they're using some metasploit like framework, which is also very well known like tools. By the way, you probably see that in my class I didn't teach a lot of like tools like the one that you learn probably in some other like sources like YouTube or something. The reason the reason that I'm not really fine into teaching the tools is that all this tool set is actually changing a lot, like over the past 10 years, because I start to learning all this kind of like security since a very young age, and back at my age, all these tools is we have a completely different tool set, right, to set up. So therefore, that being said, it's just like, say, if you really need to learn some certain concept using some like examples, then you can learn certain tools that will certainly helps you. But I don't think that teaching all this tool set is very good or idea. A better way to teach is just teach you the basic concept behind all these tools, right? And then they can also do some code and DLL injection, which I already mentioned and we already learned. So let's take a quick review about this packed and obfuscated malware, right? So first one is we can use this packing, where we know that packing means that we just try to zip the original executable files. So normally we use packer to try to protect, try to first just make sure that make our runnable program become smaller, right? So it's more like a zip version of the program, right? Just like WinZip that we use for shrink the size of the files. But we know that there's also another, this packer can also use to protect the software from like from being like reverse engineered. And also the pack program in this hackers at the hackers hand, they can use this to bypass the antivirus software. So we know that if we have the packer basically means that this is the original executable files. We can run it from top to bottom, and once you run the packer, then they actually create a packed executable. So the strings and other information not visible. I already showed you the example under Linux systems, right? You can also try it out on Badger CTF. So this and then they actually also provide this wrapper program. So when you double click the program, the wrapper program will first get executed, and then try to unzip the packed executable and then release the original executable. So that's the packed, the idea behind this packer. And then there's also another term which I already mentioned is obfuscated program, which is the ones whose execution malware author has to attempt to hide. Right? Both techniques will severely limit your attempt to statically analysis the malware, because we know that no matter whether you try to do this basic analysis, I mean the even use heuristic-based static analysis or signature-based, adding this obfuscated or packed malware will make it really hard, right, to detect. Right. So this is just a packer I mentioned. It's UPX Packer. This is a very old one, and then you know that you probably already tried this before. Right? And then there's also this PID, which is software that can use to check which kind of packers this software has. We know that in nowadays there have a more very like advanced, very complicated packers that's out there, and also there's some crack me things that they just try to challenge all the hackers or crackers. They try to see whether if you can like successfully release the original program, right, without running it. So that's the several thing about the packer. That's actually a very like complicated topics that I try to avoid, because if I'm teaching this one, there are like be another year or another 2 years to teach about this. Just all about this assembly instructions and how to like find this packer's entry point and sort of things. You can see that here they actually find us entry point of program. Anyway, so that's really not that matter. And then we have this binders. Binders is just like the idea is just like, say, they try to like putting this original malicious code binary files into benign executable files and create new files. So the malicious code binary is being written into the end of the files of the executable binder. So once you run this file C, then the malicious code somehow is also get executed. So it's more like once you double click the file C, you actually run two files together, the file A and the file B. Of course, the binder will figure out a way to let its original files to code the malicious code, right, at the same time. So that's a binder. And then splitter is like we can use also using this idea to splitting like the files and the code to to basically just try to split the files into single files into a number of small size files, from the single files into number of small size files. So therefore, we know that this might change the structure or the signature of the program, and then once you click some of the files, then they basically just combine them in real time. So they also may change some code into smaller chunk files to evade this data AV detection. This splitting the files is also very good for some of the hackers also using these techniques to try to reverse engineer the detection algorithm behind the AV software. So you can see that they try to scan it like they have multiple files. That there's this original files, and then they can be flagged by the antivirus softwares. So what they try to do is that they simply just split this one into like 001, 002, 003. Each only contains small chunk of the original files, small chunk piece of the. It's more like you chop them into multiple pieces, into 19 pieces. And then what you do next is that you're sending this all 19 pieces into antivirus software and see which part of the files, which files have been flagged. So like say if the antivirus software flags this simple 2.exe.016, then you know that your original programs, that piece of that part of the code, that portion of the code is contains something like trigger the flag. So in that case, they can do this trial and error method and try to figure out a way to bypass it. So this is a very common, I think, back in 2003 or 2000, all the way to 2006, right? In that 3 years when everyone's still using Windows XP system, and a lot of those users start to like using this internet, and then the antivirus software is still not like being well developed. So back in that time, a lot of people try to like build these malicious malwares and then use these techniques to bypass antivirus software. Of course, this no longer works nowadays. All right, so that's basically all about this static analysis and how to bypass it. So let's talk about another idea of this to detect this malware. It's called behavioral based detection. So if, like, say the malware author try everything, like try to hide this malware, right? They try to like adding this packer to pack to and then adding some like obfuscation mechanism to obfuscate all these things. But we know that the malware, eventually they're still a malware. They should be able to run and then to attack the software. So another way is to try to detect it is, why not just let it run, right? So let's say that if we can like figure out a way to safely run this malware and then observes how the program executes, right, rather than merely emulating its execution, then we can simply just identify this malware by looking for the suspicious behavior. Right? So that's the idea behind this behavioral-based detection, right? It's more like just like say instead of like tried everything to do the static analysis, why not just like simply run it, but make sure that they're running inside a safe environment. Right? Disadvantage of this, of course, there's always a risk, right? So first you need to make sure that the malware will not be able to, after run it, they will not infect the system, because you are going to like explode a bomb, like something like this. Like it's never a good idea to execute a malware under your system, right? So this is just the first disadvantage. The second is that you need also to make sure that you can find a way to capture all the behavioral, the suspicious behavior that the malware has, which sometimes is hard. For example, if I create a malware, let's say if you run it, then I'm going to wait 10 years until I'm starting to like release my starting to steal like your password. Then if you simply just using some method like immediately capture all this system information, let's see whether if I'm releasing some malwares, whether if our program is trying to starting to hook some APIs, then you can probably see that nothing happens. But if you're letting this program run for 10 years, then all of a sudden they turn into a malicious code. So that's the problem, right? So when you run this behavior-based detection, you need to make sure that you can observe all the behavior behind this malware. Sometimes it's not that easy, right? So you need to like figure out a way to trigger this malware's malicious behavior. All right, so let's talk about this a new term called sandboxing-based detection. So what is a sandbox? Right. So sandbox is just like a system, and then they try to isolate the files which are to be scanned and then monitor their activity. So this sandbox is just like a virtual environment, virtual systems. The trick malware thing that they are trying to that's the whole system they try to attack, but what actually happens is that you try to like monitoring the behavior. So now let's talk about this heuristic engines, right? So the heuristic engines is basically statistical and rule-based analysis analyze mechanisms. So their main purpose is detecting new generation, like previous unknown viruses, by categorizing and giving threat and risk grades to code fragments according to the predefined criteria. And heuristic engines are the most advanced part of this antivirus software product. They use significant amount of rules and criteria. This is something that has been widely adopted by our modern antivirus software. This is because the signature base is already outdated, and then this heuristic engines is because each company they can have multiple different like a set of rules and criteria, and they can code those rules. You're already working finished lab 2, so you know what is when I say rules, you know what that means, right? Just lines of code, and then you'll be able to you actually already implement I think 2 or 3 rules for lab 2, right? So since no antivirus company released a blueprint or documentation about their heuristic engines, all non-selective criteria about their threat and risk grading policy are found with trial and error. Right. So that's the heuristic engines. So let's take a look at this so-called dynamic heuristic analysis, which is a little bit different compared to our previous version, where our previous version is the lab 2 is the static heuristic analysis. So dynamic heuristic analysis, which is the most advanced, unless you're using some machine learning things, then this is actually just not that intelligent compared to ML based. But anyway, so this one we have this unknown sample, which is PE files should be able to execute. So we just try to run this in a sandbox system. Right. So the sandbox system. You can consider just like virtual machine, right? Like the virtual box that we use, you can just treat that one as a sandbox system, because it's a system that's running inside your system and it's an isolated one. So even if the virtual machines get affected, it doesn't matter, right? So that's more like a kind of like sandbox system. But we know that the antivirus software, they actually have their built-in sandbox systems. So that sandbox system does not provide you like the user GUI interface, but they basically do the same thing. They try to run these PE files and then try to gathering all this information, right? The only difference is that they're not VirtualBox, right? And then after you run this program, then they're gonna generate the log files. The log files generated by your sandbox. So they basically just try to monitoring all the behavior of this unknown sample, logging the function call, parameters, and everything. And then finally, they try to extract the malware's fingerprint. So this malware expert using these log files to find the key features and add it to this malware database. So that's the idea behind the dynamic heuristic analysis, right? So you can see that the key part of this is the sandbox system and then how to generate the log files. Or to be more specific, the sandbox and malware's fingerprint is also considered the most important part. So first is how good your sandbox is, right? Do you think that you can trick this malware to think this is the host machine, right? So this is the first thing. The second is that how good your fingerprint is, right? Whether you will be able to like try to find out the precise fingerprint. Otherwise, if you find something that is very like common for other like benign programs, then you know that there's gonna be a lot of like false positive rate. It's gonna be high, right? So here's some of the known rules about the threat grading, right? So I don't know what's the threat grading system that our existing malware system antivirus softwares use, because they just keep it as secret. They're not open source. But you can see that it's basically just something that they check, right? So they see whether there's some like decryption loops detected, whether the program tries to read active computer names, read the cryptographic machine, GUID, contact random domain names, drops executable files. That's gonna be very suspicious. Normally, the program not drops executable, not release executable files. Modifies some proxy settings, injects into Explorer, install hooks and patches in the running process. I think most of the times that when you try to like run some softwares to do this, then they're gonna be categorized as a very high risk program. So if you try to run install hooks and patches to the running process. But if you're using some like if you play games, then you know that sometimes when you try to use some like a cheat engine, right, those kind of things, they also need to hook the running process, and that will trigger the false alert of your antivirus software. Or if you try to play some like Japanese like games and you want to like translate in real time, you also need to use some of these conversion or translation softwares, and those softwares also use the similar technique using the hooks and patches, and that will also trigger the alert of our antivirus software built into the Windows 10 system. Anyway, so that's this just about the threat grading. I'm not going to read all of them, but you got the idea, right? So they just try to like categorize each and every suspicious like activities, and then give them a grade. And then if your program violate a lot of rules in this list, then they are going to detect. They're gonna like think that it's gonna be a malware, so they're gonna prevent you from running it. Okay. So here is the table shows you the pros and cons of these two ways of the detection mechanism. Static heuristic analysis, the one that we use in lab 2, is fast and easy, of course, because just rules based, right? Just scanning the malware, and then but the problem is that it cannot handle the shell and code obfuscation, because that is really hard, right? There's just concealed all this kind of like code, so we cannot like running scanning those kind of files, unless we can adding more code to try to like decipher it, right? And dynamic heuristic analysis will be much more easy, because in that case we can actually reveal the malware, because as I mentioned, eventually the malware need to attack the computer, your operating systems. So if you run it, they're gonna like, no matter what the shell or code obfuscation that the author used, they still need to release the actual malware. So in that case, this is gonna be like easy for us to immediately try to like record the behavior. The cons is that may attack by the virtual machine technologies. So there's a lot of different like virtual machines, anti-sandboxing technologies. They're going to basically the malware, if they detect this is they're running inside like a virtual machine, VirtualBox, then they're going to stop running, or they're not going to running at all, or they may act like benignly. So this is just like the cons of this dynamic heuristic analysis. So that being said, in short, it's just like sometimes it's really hard to like find all the record all the behavior of the malware. Right, so this is just, it's a very challenging part of this dynamic heuristic analysis. All right, so in the first experiment in today's lecture, we want to I want to give you an example to show you how to do this dynamic heuristic analysis, how to monitor the behavior of a ransomware, and then generate log files and then analyze it. right? So first, what is a ransomware? Ransomware is a type of malicious software or malware designed to deny access to a computer system or data until a ransom is paid. So I think nowadays everyone know what's this ransomware is. It's very like being attacked. I think they have a lot of like different. I think WannaCry is one of the ransomware, right? So and also the crypto locker. So basically, just try to like lock all your files and using this RSA 2048, those kind of public key encryption mechanisms to encrypt all the files. So unless you pay the ransom, paid money, like using Bitcoin, there's no way that you can decipher or to unlock and decrypt the files, right? So and also I can say that this is actually true because this is been proven by our mathematical formula. So unless you have the private key, there's no way that you can restore all these files, right? Even if you find a hacker, they cannot do that unless the hacker have your keys, right? So that's actually a very powerful attack, right? We know that there are some ways to if you have supercomputer, then you probably will be able to decipher it, but that will cost maybe much more than this in this $300, right? So that's the problem. Anyway, so that's the ransomware. That's just try to encrypt all your files, right? So let's try to take a look at this experiment. So here I prepared a malware, which is toy malware. It's not a real ransomware. It's not gonna encrypt the files, but what this malware's behavior is that they're going to try to find all the docx files in the, which is the Word files in the current folder, and then they're going. This malware is going to change the file name to the crc32, the hash value, and change the file name to crc32. Right. So change the file. I think it's the file extension to something .crc32. And then use the first 16 byte to do XOR with 0x01 to simulate the file encryption. So all these files will be encrypted. And then after that, they're going to generate the text files, ask for money or Bitcoin. Right? So that's some ransomware. And then eventually they're going to delete itself. I think there's and this, as mentioned, this is the best way to protect itself. So most of malwares actually do this. They try to release malicious softwares and then do all the job and then immediately delete itself. So therefore, you cannot, if you cannot like capture this that malicious malware like before it delete itself, then you cannot like analysis it. So this is the malware that I created. It's not really a malware. It's more like a toy one. But we can use this. It's very similar to the real ransomware, right? So let's see how to like use the sandbox system. Use this dynamic heuristic analysis to detect this malware. All right. So first, you can download this zip file ransomware from our class website. Once you download it, and you can just double click, and then gonna shows you all the files inside this zip files. So first we need to extract all of them into a folder that you need to make sure that you extract them into the folder called C, and then click select new and then create a folder called test. Right. This is very important because actually I hard coded this software because I hard coded this software. So this malware, so it only works if you put them into C test folder. So it's very strict. And then all you have to do next is simply just right click here and then select extract all, and then just put them into this C test folder. So you can click browse and then select my computer, C, and then test. Right. So go to, or you can type it here, C test. Right. And then select next. Then they're gonna ask you to input the password. So as usual, the password is infected. Right. So just type this up, and then they're gonna extract everything. Right. So okay. So now we can start to work on this lab, working on this experiments. So in this experiment, we're gonna first, you can see that there's a folder called scapegoat. Right? So if you go to this folder, you can see that they contains 5 Word files, right? Scapegoat01.docx, that's a Word files, right? So usually, if this is a Windows system, like Windows 10 system, we can actually preview the files even if you don't have the Office. But we know that this is Windows XP system, and there's we didn't install this Word, so therefore they not recognize this file format. But doesn't matter. We know this is just our Word files, which will be encrypted later. And we have this monitor files, which is the one that I use to simulate the monitor in our class. The monitor basically just keep recording all the suspicious activities. We have this monitor. This is a CPP file. It's the source code of this monitor program. We have monitor.py with this, which is the Python files. Okay. Anyway, so this three, you don't need to worry about these 2 files. This is just like the source code. So okay, ignore that, and then you can simply just all you have to do is just delete this this underscore line at the end of the file name, right? So we know that it's the virus upx.exe, and then there's an extra line here. So you just delete this one, right? And then once you delete it, well, both of them will become executable files. So this is the virus, and this is virus UPX. UPX is just a packer, right? So we know that you can use this UPX to add packer to this malware, right? Okay, so now first you need to do is to double click this monitor and then click run. Then you can see that they actually pop up a window, a terminal window, shows you that they start to monitoring the system. And then you can also see there's a log files being created. Currently, this log file only have 0 kilobytes, so that means this is actually as empty files. All right, so now let's run the virus. As normally, we're now running virus, but this is a virtual machine, so it's fine, and we know exactly what's gonna happen if you double click and run the virus, right? So because we create this virus, the virus source code is or is known one, so it really doesn't matter. Okay, so let's double click it. Once you click run, you can see that our inside this black windows, inside the terminal windows, a lot of things being like right here, right, being written, and then you still keep reading. I think there's some bugs in my monitor program, but doesn't matter. So let me just close this one. So once you close, then this time you can take a look at this log files. But before we take a look at the log files, we can first take a look at this folder. If you go to this folder, you can see that all the files is now changed. The new extension is .crc32 is no longer .docx, so that means this files has been encrypted, right? So we know this files is actually the first several bytes is being encrypted by XOR with 0x1, which is but the actual file content is not encrypted. So just try to simulate what how this ransomware works. And you can also see that the virus.exe program disappeared because, as I mentioned, they're gonna delete itself at the end of this running, right? And then so let's take a look at this log file, see what is the stuff we captured. You can just select open with Notepad, right? You can see that a lot of things happen. First, they have rename the files from this scapegoat01.docx into this number.crc32, and then they modify, and then they also capture another modify, and then rename, modify, right? So they actually modify every time there's a modify, that means they try to modify the content of the files. Rename, it means that they try to rename the files. So basically with the virus, the so-called toy virus, try to like modify and rename all these files, and then create a new files called readme and also modify it. So let's take a look at this readme files. All right, so you can see that this is a ransomware, right? So that's just a readme that generated by this virus. And then And then after that, this is this file create delete self.cmd, which is command line files, modify log.txt, and then file delete virus.exe. So you can see that this virus is actually a self-deleted one. They deleted the self. They also deleted the self.cmd. This is command line files. Both files been deleted. So that's the virus. All right. So you can see that now we have the log files, and this log files precisely recorded all the behavior of this malware. So in that case, we can simply just using these log files and then using any like coding technique. For example, you can use in Python. That will be your next lab. You can use Python to analyze this log files and then to detect the malware. So okay, so that's this the experiment. Actually, there's also another one called the virus UPX. So let's try to run this virus UPX first. But we know that this the scapegoat files is this one is already encrypted, so we need to restore the files. So how to restore it? We can simply just we can simply just go back to download and then extract all the files, the original files. Okay, so let me just putting them into repeat this one. I'm putting them into the test folder. Yes, tool. Right. Okay, so now let me just recover these files. You can see that there's all the files is there, and then the scapegoat, they have the CSA32 one. We can just delete them. We no longer need them because we know that they're going to be generated very soon. So now we just only keep this DUCX file. So this file is about to be encrypted again, and then we just double click this monitor and then they start monitoring. So this time I'm going to try to run this virus UPX. We know this is actually the same virus, the same ransomware that I created, but this one is been encrypted by adding a packer, right? So this UPX packer. So normally this virus can now be like analysis using the technique that we learned in lab 2, right? So you can now like static analysis it. Well, at least not that easy to be analysis, but somehow we can still use this dynamic heuristic analysis to find the behavior. So let me just run it. So once you run this virus, you can see that the behavior basically is the same, right? So we got exactly the same thing that been put into the log files. So this is the new one, right? You can see that basically the no matter whether if you're adding a packer or not, or doing some code obfuscation, it really doesn't matter. As long as you run the malware, you do this behavior, that will be recorded. So that's the advantage of using this dynamic heuristic analysis. All right, so that's the first example about the dynamic heuristic analysis. All right, so you're probably gonna wonder how to create this monitors software, right? So because you can see that this one we have the monitor to the sandbox is the virtual box, and then we have the monitor program which generate the log files, right? So the monitor program, basically I'm just using a very simple Windows API function. It's called read directory change W, right? So this read directory change W function is basically allows us to retrieve information that describe the change within a specific directory. So that's the reason why that I said that you have to use the C test folder to run this malware, because when I write the code, I just use this function. I just calling this function and then only monitoring the C test folder, which is fine because considering that the malware is running inside a so-called sandboxing system, so we can consider that the sandbox is only contains one folder, specific folder, and then we use this function to keep monitoring that folder. So we don't have to monitor all the folders because, again, as I said, all this malware sample will be first putting into a sandbox system. which means that we can define the folder's name. And then basically they are going to allows us to passing all these arguments, right? So we have this H directory, which is handle to the directory being monitored, and then we have the buffer, which is pointer to dword aligned 4-meter buffer, and then we have the buffer length and things, and then eventually the most important one is to set up the notify filter to see which things should be like recorded, right? So we can see that they actually support like the change of the file name, change of the directory name, change of attributes, change size, change last write time, last access time, change the creation, change security, right? So basically, that's the all the things that we do. Basically, we try to monitoring whether if it's been renamed, modified, if the program is being modified, or being deleted, created, right? Something like this. So you can see that it's just one function, right? It's still very simple and very easy to understand. Okay. So anyway, so that's the idea behind it. Of course, this is just a toy program, right? So it's a toy virus and then a toy like monitor program, but it shows you the key idea behind this heuristic, dynamic heuristic analysis, right? So you can, of course, you can just adding a few more lines of code, make it more robust, and then create a more like a better sandbox instead of using VirtualBox, and then after that you actually have like full-fledged antivirus software. Right, so that's the first experiment. Right, so let's take a look at the second experiment. So the second experiment is about this API hook. So we know that in the previous examples, it shows you that we can use the this monitor, this program to monitoring a folder and then see whether there's some certain behaviors of a malware. But we know that all we do is simply just use this the only Windows API. The only Windows API read directory change W function, and that function has some limitations because it can only like read the change of the folder. For example, if there's like some changes of the and can only monitoring one folder, right? So we know that we got the idea, the big picture of it, but still this is not like perfect for creating antivirus software. So in the second experiment, we are going to create another like virus. So first, let's take a look at this virus. So this virus, of course, is just a toy one, right? So the name is called the virus. So this program is actually a dropper, right? Or whatever you can consider as this one is going to generate. They're gonna release a virus called virus.exe into a folder C Windows System 32. Right. So we know that in Windows systems, normally most of the virus or malware, they're trying to like write this System 32 folder, because if they can place their program into that folder, then most of the time we'll treat it that as a system program. So normally, all this benign software, they most of them never like try to write this folder. But our malware, we can this malware is going to try to like putting itself into the System 32. So that's the first behavior. They're going to copy itself to this System 32 folder. The second behavior is that after they copy into that folder, this malware will immediately calling this create process W function to run this virus, right? To run this program. Okay. So that's the behavior of this virus. So now let's take a look at how to like monitoring this program, how to create it, how to use the same idea to perform this dynamic heuristic analysis. Right. So in order to monitoring this virus, all this behavior of this virus, we need to use the idea of the so-called API hook. Right. So remember that in 2 weeks ago, in the previous lectures, I showed you what is a API hook. Right. So I used the example this stealth process as an example. Right. So shows you that how to use this API hook to hook a certain functions like ZW core system information functions, and then to tweak the functions once you hook it. It's just like adding a detour function of it. Right, so I think that I have pictures to show you the idea. Where's the right here? Right. So the idea is that API hook. The idea is that basically we just create the detour functions here. So that means every time if you try to calling create file function, because create file function is being hooked by the if there's some other program try to do this API hook, then every time you call create file function, you actually calling this my create file function, which is a detour function, and this my create file function will call the real real create file function to create the files. But it's more like the one that the my create file function is one that placed in the middle. It will intercept all this information. So that means you can easily like tweaking the information in between these two function calls. So basically we borrow the same idea. So back to our class. So in today's lectures, we want to, in this experiment, we want to monitor the behavior of this virus, because we know the virus do two things. First, they try to copy itself into a system folder, system32. Then they try to to run itself. So that means we need to hook two like APIs, Windows APIs. That means every time they try to like copy itself, they're calling Windows APIs. If that Windows APIs is being hooked, just like this way, then we will be able to detect that behavior. So here you can see that in this monitoring program that I created, which later I'm going to show you. In this program, I create first I create a function called myCopyFileA function. So this myCopyFileA function is the one that we're going to replace the copy file function. Right? So this is our own copy file function. So what happens inside this myCopyFileA function, our own version copy file function, is that first we're going to unload the hook, right? Just like what we do in the stealth process, right? So in the stealth process example, I shows you the behavior of this API hook in the assembly level, right? So you can see that inside the assembly level, we first try to unhook the hook, then call the real function. Then we try to reload the hook. So here is the same thing, but this time we are trying to read them on the C level, right? So this is the source code level, right? That is the assembly level code. So first we try to unload the hook, then we're going to write the function behavior into the log files. So that means every time if some program try to call copy file function, they're actually just calling this copy file A function, myCopyFileA function, and then we're going to inside this new version of these functions, we're going to record such behavior. Right? So that means someone is trying to first we're going to create the log.txt files inside under the C drive, and then we're going to write down which files being created at which directory. And then once we done that part, then we're going to rerun this copy file function, because eventually the malware is calling the copy file function. So we intercept that. But since we are not like really the one that are going to to stop this behavior, instead we simply just we still want to keep monitoring it. So we just recorded this behavior. And then we're going to coding this the actual copy file function, the copy file A function, right? So we're coding it, and then passing all the argument the malware is supposed to pass, and then let the malware to create that files. and then we're going to unload we're going to reload hook. So next time the malware try to calling this copy file A function, they are going to still copy our own version, which our own version is more like just like only act in the middle. It's just like the detour function that we created here, and then we're going to inside our detour function, all we do is just like write down that behavior into a log files. Same thing, we're going to also hook this create process function. So I create a function called my create process w function, which is just used to act as a detour function of the create process w function. So the logic is the same. First, I try to unlock the hook, right? So just unhook the create process hook, and then we're going to write down that behavior into the function behavior into log files. So someone is trying to run a process that will be recorded, and then after that we're gonna actually rerun this the original create process function. So therefore the malware is able to actually execute it, which is fine because that's a sandbox system. We just want to keep monitoring this, the behavior. So we still need to let it run. So this is a rerun the create process function and then reload the hook. So the next time the malware try to calling the create process w function, they're also going to run into our own like my create process w function. So you can see that the antivirus software and the virus software basically use exactly the same technique. So that means that all these techniques, API hooks, kernel rootkit, SSD hook, SSTD hook, those everything that we learned, it can be either used in the malware or you can use that into the antivirus software. Just depends on which side it's in, right? Okay, so now let's try to so now once we know this, we know that basically we expect once we run this monitor program, and then after that if we run the malware, we expect that they're going to generate the log.txt files under the C drive, and then you should be able to record it all the behaviors, the suspicious behavior of the malware. All right, so let's try this. Alright, so once you are inside Windows system, this time you can download the zip files called API virus, and then unzip it, and then also with password infected. Right, so that information is also available on our class website, and it's very similar to the first experience. So I'm not going to repeat it. So first they're going to double click and run this test program. So once you run the test program, it's just very similar to the previous monitor program, right? So they're gonna create this window, and then we just double click and then run this virus program. So remember that normally it's not recommend, or you should not run this virus like directly under your host machine, but since this is a virtual machine, it's fine. So you run this virus program, and it's supposed to copy itself to system 32, right? So to this Windows system 32, and then also try to run it. So you can click this run, and you can see that this time the virus software is actually been start running, right? So there's actually pop up another like window, and then now we can close it, right? And then now you can see that there's a log files that have been created, and then you can see that inside this log files they actually already recorded this behavior. And I think there's also should be log files that's available on our C drive, under C drive. So you can close it. You can see that, okay, so this is the log files that have been generated, because according to the source code, you can see that all this behavior should be written into C log.txt. So we are actually, this is the files, right? So if you open it, you can see that they actually successfully capture these two behaviors of this virus program. So the first behavior is that this virus program try to copy itself from our download folder, which is the unzip folder, into Windows System 32. Then they try to call the create process to run itself. Okay. So that's, of course, if you ask me what is the behavior of the virus, it's just nothing gonna happen, right? So it's just the source code is, sorry, not this one. The source code is here. You know that they don't do anything. It's just wrong, right? They just run itself, and then that's it, right? So there's really no other malicious code in it. But now you know that this API hook one is more close to the actual behavior of the antivirus softwares, right? So all our real antivirus softwares, they try to like hook your system APIs, just like the way that I hooked this all this program, right? So and also there's also a DLL main. Is actually we need to figure out a way to inject this DLL, but that's very trivial things. And then all you need to know is that this API hook is the one that most of the antivirus software use, and you can use that to create as a heuristic the behavioral based antivirus software. Alright, so I think that's pretty much all for today's lecture. So in today's lecture we studied how to create the antivirus softwares, right? So starting from the basic fingerprint based, then we'll also move to the heuristic based, and then we'll talk about this dynamic heuristic analysis. All right, so we're gonna have our you're going to have the very last lab of this semester, which in that lab you are going to rerun this experiment 1, this the one that generates log files, and then you need to write a Python program to analyze these log files, and then to detect to see whether if this is a malware or it's not a malware. Right. So more details will be put into this the new lab's PDF files. You can follow the instructions to complete it, and that's going to be the very last lab of this semester. Of course, we also have the final project. All right. Thanks for watching. So that's all for this week.